Welcome to my channel Data Engineering Simplified. In this Snowflake video series, we will learn everything about Snowflake and gain hands-on experience on every unique feature of Snowflake using Snowflake Free Trial Edition. I hope you would enjoy this visual guided tour on Snowflake. So let's start with our third chapter, Snowflake Architecture. So what we are going to cover in this third chapter, we will primarily cover what is that shared disk and shared nothing architecture, Snowflake's hybrid architecture, which makes it very unique. Three-layer services, storage, compute, and service layer. Snowflake at a glance, Snowflake capabilities and unique features. So, what is covered in this chapter and what kind of questions you would be able to answer once you complete this video tour? Snowflake is a software as a service SaaS model. Sometimes it is also called data platform as a cloud service or data warehouse as a service. How Snowflake is different from traditional data warehouse systems. It's three unique layers called storage layer, underneath cloud storage which is compressed, secure and encrypted, compute layer which is nothing but a flexible compute layer and also called virtual warehouses, cloud service layer and also called brain of the Snowflake and which serves following purpose: authentication and authorization, whether you connect through the classic WebUI or via connector or SnowSQL which is a CLI or a native connector. It also manages user and session management, query compilation, optimization and data caching, virtual warehouse management, coordinate data update and transaction management, metadata management, which is one of the key component here, which support zero copy clone, time travel, and data sharing. Manage and maintain the lifecycle of a query. And finally, virtually infinite scalability and decoupling of services, storage versus compute versus metadata, which is one of the unique capability of Snowflake.
So before we start, I request you to look into my Snowflake playlist, which covers a lot of topics like SnowPro certification guide, SnowPro certification tutorial, Snowflake connector series, Snowflake features and limitation, and many more such videos. I am getting a lot of positive and constructive feedback from my audience, a lot of success for my certification audience, and those certification videos are very popular. So please subscribe to my channel and click on the notification button to get notified of my latest videos and be the first to know more about Snowflake. You can also follow me on Facebook, Twitter, and LinkedIn.
So let's talk and pay a little bit extra attention to the traditional data warehouse architecture. We know there is one architecture called shared disk architecture, and other side we have a shared nothing architecture. Both are distributed computing architecture, and let's deep dive how does it look like. So in a shared disk architecture, you have a disk which is also called storage, and you have a compute which is nothing but a processing, and in general we access those compute through the SQL statement or ETL jobs. So the multiple nodes, or we can say compute resources like BI, dashboard, or developer ID, etc., access this single storage system using the multiple compute environment. It has a single point of failure because it's a single disk, cannot scale beyond one point. That is one of the limitation. As it scale ups, or we can call it vertically scaling, it becomes more and more expensive. The system becomes very slow as you onboard more and more ETL workload, and scalability and elasticity is one of the core drawback in the shared disk architecture. On the other side, when we talk about shared nothing architecture, each node in the cluster has a portion of the data along with computing power. No single point of failure in this architecture. Add more and more nodes and it can scale horizontally. However, compute and storage cannot scale independently, and that is one of the limitations in this architecture. As it scale out, the administrative cost increases. Shared nothing architecture supports only eventually consistent data consistency and having it a tight couple between storage and a compute. So this is the two popular architecture what we have seen. Let's see where other popular solution fit. So when we talk about Apache Hadoop, which is a distributed computing, storage, and compute engine, we have a problem here that the storage and the compute is tightly coupled. So HDFS is a distributed storage and MapReduce is a distributed compute engine. Each node has storage as well as compute capacity, and workload is managed by the yarn. In the other side, we have Apache Spark, which is purely a compute engine, a distributed compute engine, which works on the concept of resilient distributed dataset, which is called RDD. It is a pure memory computation engine that runs on the top of Hadoop ecosystem in majority of the cases. Spark can also read write data from N2, S3 and other cloud storage providers. Cloudera Impala is one of the most popular massive parallel processing execution engine, and it is based on very close to the shared nothing architecture. However, it does not store the data. It needs a high meta store to operate. This is also in-memory query engine and runs on the top of Cloudera Hadoop distribution. One of the limitation Impala has it that it does not have a failover. So if it runs out of memory, it cannot recover itself. You have to restart the job. Cassandra is purely shared nothing architecture, and it also has a limitation of eventual consistency concept. Most of the traditional enterprise data warehouse solutions are primarily MPP engines, and they are very, very expensive. And as you have to scale out or scale up in either cases, these systems are having a lot of limitations. So what makes Snowflake architecture different and unique? So let's get into Snowflake architecture. So we have seen the shared disk architecture and we have seen the shared nothing architecture and their limitations and their core capabilities. So what Snowflake does? Snowflake follows a hybrid approach in which it decouples the compute and storage, and so they can scale them independently. So it is called multi-cluster shared data architecture. Full advantage of the cloud native feature, which is again elasticity. So it combines these two architecture and make a multi-cluster and the shared data architecture. So Snowflake has a 3-layered unique architecture. So we'll go through each of them. So first layer is called data storage layer. Underlying cloud storage. It could be S3 for AWS, Azure Blob for Azure, and GCP bucket for Google Cloud. Virtually infinite storage, because you can buy storage in cloud, and Snowflake uses the underlying cloud storage. So it can scale to any number. All the data in Snowflakes are compressed and encrypted. So you don't have to worry about compression and encryption. It is fully secure. It takes the privilege of cloud data redundancy, so you do not have to think about a data loss anytime. You pay only for the storage which is used. In other architecture, as you increase your compute, you also have to increase your storage. And even though the storage is not used, you have to pay for the storage. But that is not the case for Snowflake. You only pay for the used storage. Next layer is compute and processing layer, which you can think more like a Spark or Impala. Also called query engine or a virtual warehouse in terms of Snowflake. Underlying virtual machine could be EC2, Azure or GCP machine. Scale up and down as needed. It is not infinite but big enough to accommodate any workload. Different size to serve different workload. Now the third layer, which is called cloud service layer, and which is also known as the brain of the Snowflake. It takes care of authentication and authorization. So you may have 100 users or 1,000 users or 10,000 users. This layer is responsible for managing users' authentication and authorization. It also manages user sessions and user management. It also takes care of query compilation, optimizing the queries, and data caching. It also manages the virtual warehouses, which is actually running the different workload in your Snowflake account. It also does the metadata management. So each layer can scale independently, and that is one of the unique feature we have. If you have a data storage intensive application, you can store as much as you want and you only pay for what is required. If you have a compute intensive application, then you can use as much as compute you need and you only pay for the used compute. And cloud service layer is a layer which can scale to any number of users, and it can manage many other things within the Snowflake. So different workload can be served. For example, store more data and less compute workload, store less data or more compute workload, store more data and more compute workload, provision your compute as per your workload. So you can scale up and make a right selection according to the workload. Provision compute only when needed. So you don't need to run your compute all the time and wait for a query to be executed. So when the query is fired, that time you can really bring your compute. And once the query is done, the compute goes away and you only pay as long as your compute is running. Pay only for the usage, storage, as well as compute. So, and many more such possibilities are there within the Snowflakes, because it comes with a lot of unique features, whether it is encryption, whether it is a data storage, whether it is a different file format, and many things. So let's explore how the storage layer works in Snowflake in detail. So Snowflake store all data into database, and the database is a logical grouping of objects within the Snowflake instance, very similar to the traditional data warehouse or database systems. These objects are primarily table, classified as a permanent, temporary, and transient table. And it can also be a view, which could be a standard or a materialized view. Again, it is a very simple and a common concept across all the databases. These objects are part of one or more schema. So Snowflake follows a standard approach of organizing database and schema, and all the objects are part of the schema. You can store any structured relational data, standard SQL data type, or a semi-structured non-relational data like a JSON, Parquet, Avro, ORC, XML. These are called variant data types. Snowflake uses highly secure cloud storage to maintain your structured as well as semi-structured data. As data is loaded into the table, following activities happens. So pay attention to this flow. Snowflake convert them into optimized columnar compressed format that is proprietary to Snowflake. These optimized columnar compressed format brings a lot of data access efficiencies, so faster workload, low compute, and storage cost. And encrypted AES 256 strong encryption. Based on the cloud platform, data is loaded to the cloud storage. It could be S3, Azure Blob, or GCF bucket. However, this is not visible to the user how it is stored and retrieved, and overhead is taken care by the Snowflake. So you cannot simply go to S3 and access those encrypted data. It can only be accessed through the Snowflake WebUI or Snowflake connectors. So that gives a level of security to your data. This compressed and secure data is accessible only via SQL, and there are no other means that it is accessible. Data storage cost is calculated on a daily average amount of data in bytes, short-lived or a long-lived table. So you can create a short-lived table like a transient table, or you can create a permanent table, a long-lived table. If the time travel feature is enabled, it is also part of the storage cost. So if you have enabled the time table for a permanent table or a transient table, your storage cost will increase. Let's talk about the second layer, that is called compute layer, and how does it work. So compute layer is where your queries like select queries, join queries, data loading, stored procedure, etc. are executed. Before any query is executed, compute machine need to be provisioned, and in Snowflake it is called virtual warehouses. The virtual warehouse compute resource has access to the same data storage or the data layer. So that's why it is called shared data multi-cluster architecture. You can choose a virtual warehouse as per the workload required without any contention or a performance degradation. We will cover in detail when we talk about virtual warehouses. So this is how it looks like. To create a virtual warehouse, you simply give a name and the size. Bigger the size, more the compute power and more the cost. And Snowflake handle all the provision and the configuration of underlying compute resources. In case of AWS, it could be a EC2 instance, and in case of a Azure or a Google, it could be a VM. So if you can go for extra small, you can go for small, which is a 2-node cluster. You can go for a medium cluster, which is a 4-node cluster, or you can go for 4x large, which is 128 nodes. The virtual warehouses can be scaled up and down anytime during the query execution without any hiccup. One of the unique feature. When rescaling is done, all the subsequent query takes the advantage of a new size of the warehouse. So for example, you are running a BI dashboard and your queries are taking time because they are on the wait period. You can go and you can change the warehouse sizes and double it. And as soon as you double it and the provision is done, which takes hardly a few seconds in a case of a Snowflake, all the subsequent queries will be served, or all the waiting queries will be served by the new instance without any hiccup and without any extra maintenance. And that makes the Snowflake so unique. When multiple virtual warehouses or different sizes are running in parallel, Snowflake takes care of a concurrency, so you don't have to worry about it. So Snowflake will take care of concurrency, how to manage and which query will be served by which node. You don't have to really worry about anything, and Snowflake takes care of that. Now let's explore the third layer, and one of the most important layer which generally we pay very little attention to, that is called cloud service layer. So cloud service layer is also called the brain of the Snowflake. The cloud service layer also coordinate and manage the entire system. This layer is completely independent of the storage layer and the compute layer, and Snowflake ensure that is highly available. So redundancy and the fault tolerance is a core of this service layer. This layer ensures and take care of following things: authentication and authorization. So whether you are connecting through the classic or a legacy web UI, whether you are connecting through any kind of a connector, whether you are connecting through the SnowSQL or a native connector or CLI or a multi-factor authentication, this cloud service layer will make sure the authentication is done and the authorization has been checked. It also manages the user and the session management. So if you are connected with SSO, or a particular user has enabled the multi-factor authentication, in that case, the cloud service layer is responsible for validating it. It also responsible for query compilation, optimization, and data caching. Virtual warehouse management, coordinate data and storage update, and the transaction management. So transaction management does not happen in the warehouse level. The transaction management is taken care by the cloud service layer. Metadata management, one of the core activity, and this feature supports following things like a zero copy cloning, it's a time travel, data sharing, and the caching. Manage and maintain the lifecycle of a query. So when you fire a query, this cloud service is responsible to submit the query to the warehouse, making sure the warehouse is available. It gives the result back to the user. The service layer is highly scalable and distributed across multiple availability zones, so you don't have to worry about it. Let me walk you through the life cycle of a query, which we also call a workload. You can have any number of connection virtually infinite via any different supported client connector provided by Snowflake, like classic web UI, SnowSQL, JDBC driver, ODBC driver, Spark connector, etc. The cloud service layer uses cloud native infrastructure to scale up and down as a consumer of this service. We don't even see it, and everything is taken care by the cloud service layer. So you don't have to worry about its latency or whether you have to add extra node to serve more customer. When we submit a query, we can call it a workload. We also indicate Snowflake what kind of compute, whether it is extra small or whether it's extra large, we intend to use to serve our query. So compute equals to virtual warehouse, and we give a size to this query. The cloud service layer first create a session and check if the user credential, which is authentication part, is valid to use the Snowflake account, including multi-factor authentication as well as IP address policy if applicable. So you can also define that only these IP addresses are allowed to access my Snowflake account. Once the authentication is done, the following activities happens. The query is parsed, that is called a logical plan, and that is done by the cloud service layer. All the object and operation in the query, including warehouse compute object, is validated if the respective user has a necessary privilege to access those objects or not. That is again authorization part. Then an optimized query plan is generated. Finally, the service layer sends a query execution instruction to the virtual warehouse. It also resumes the requested warehouse if suspended, or spin up a new one if it is a multi-cluster virtual warehouse configuration. Finally, the query is executed. The result is returned to the user or the client program. Virtual warehouse allocate resource as needed, so you don't have to worry about it. You just have to specify the name of the virtual warehouse, and under the hood the name knows how many nodes are required to bring this cluster up. Request any data needed to run a query, so it will go to the shared disk and it will try to pull the data. So what you manage in this entire life cycle? So Snowflake admin just have to create user and that's it. Entire infra and provisions are managed by Snowflake. Snowflake take care of starting and stopping compute as per your SQL instruction. All security features are inbuilt. Just enable and Snowflake will take care of it. All optimization and security features are taken care by Snowflake. So you don't have to manage much in Snowflake. Most of the features are inbuilt and infra is completely taken care by Snowflake. No need to worry about release, patch, scaling, etc. It is taken care by Snowflake. Focus on building your SQL object, role security, and run your business. That's it. So let's look Snowflake at a glance, how your day would go as a developer in Snowflake World. So the day one, I have a lot of data in my cloud storage. Can I load them into the Snowflake? Map them to an external table or use storage object or Snowpipe object and load the data to your Snowflake environment. Easy. You pay only for the storage usage. Use small compute for small data, large compute for large data set. So you can have S3 bucket, you can have as an external table, you can have a copy command from a Google bucket, or you can have a Snowpipe object associated with your Azure integration object. Day two, I have to perform some small ETL workload. Run your query using extra small warehouse. Day 3, I have another ETL job, but it is taking too long to run. Create a new virtual warehouse and run your ETL job in the small cluster, which is a 2-node cluster. Day 4, 2-node cluster is still not sufficient for my workload. What should I do? Alter virtual warehouse and make it a 4-node cluster and see the performance. Fire an alter statement and upgrade your cluster from 2-node to 4-node. Day 5, I have a many BI, Power BI or Tableau user who wants to access the warehouse table and generate the report. What virtual warehouse should I use? So you have a multi-cluster virtual warehouse. Create an elastic or multi-cluster warehouse and it automatically scale up and down as the number of BI user increases to cater the concurrency and still give the same faster result. I have a data science team and they have a compute heavy workload. What should I do? Allocate 8-node cluster and allow them to run the machine learning job. The development team can use the development virtual warehouse for all development activities and no contention anywhere, as everything can scale up and down independently without any administrative effort. So you can have your development ETL virtual warehouse and all your connectors or drivers can connect to that virtual warehouse to access the same data. So this is how the Snowflake looks like at a very high level. So let's have a quick recap. The Snowflake capabilities and unique features in a nutshell. So software as a service, we have seen everything is taken care by Snowflake except your role security, your table design and database design. In AWS world, we have a Redshift. In a Google world, we have a BigQuery. In Azure, we have a Synapse or Databricks on Azure. They are also different alternative of Snowflake, but all of them are having certain limitations, and Snowflake is a very unique and have a lot of unique features compared to these tools. Only built for cloud and supported in 3 major cloud platforms, so you would not get any on-premises version available for Snowflake. Virtually infinite scaling. You can store any amount of data and you can ask for any amount of compute. Fully ACID compliance, however recommended only for OLAP kind of a workload, not for OLTP. Support ANSI SQL standard and all standard SQL statement works in Snowflake. Whether it is DDL, DML, SQL function, analytical function, UDF, stored procedure, it supports the JavaScript too. And views standard and materialized and secure. No indexing, no performance optimization, no partition, no physical design required. Cluster key for terabytes of table and search optimization for very point lookup queries. Though it is easy to say that you don't need to do any kind of optimization, however, some standard optimizations are required when you are writing a big and complex query in Snowflake. So don't assume that Snowflake will solve all the problem. However, for a large table and fairly medium complex query, you don't have to really optimize anything. The cloud layer of Snowflake is smart enough to optimize and implement a very efficient plan to pull the data and show the result. All security features and compliance enabled, including inbuilt encryption and compaction. So you don't need to worry about file format and compression while storing and retrieving the data. All major data format can be loaded to the Snowflake like CSV, JSON, XML, Avro, ORC, Parquet. Binary data type is also supported. It is not a binary data format. So if you have a PDF or if you have any kind of MIME type data and you want to store in the Snowflake still support those kind of binary data to be stored. Connector. So you have a lot of connector like SQL client, CLI client, JDBC, ODBC, Spark, Kafka, Go, Node.js, Python. The list is growing. Virtual warehouses comes in a many flavors. So it starts with extra small where you have the cluster with one node. It goes to the two node cluster up to 128 node extra large cluster. Multi-node cluster up to 10 cluster. Each cluster is having 128 node. It means you can really run a virtual warehouse with 1280 nodes. You can have auto resume and auto suspend as a configuration. Scale up and down as per the query concurrency workload for multi-node cluster. Time travel like Databricks Delta Lake up to 90 days. Zero copy data clone. Cross cloud DB replication. 7 days fail safe. Data sharing, reader accounts, and data marketplace. Role-based security and discretionary access control plus role hierarchy, data masking, IP whitelisting, resource monitor to control the cost. Everything in SQL object and all activities can be done via SQL statement. So that makes your life very, very easy and you can automate a lot of manual stuff through the SQL statement. And SQL is a very, very common language for majority of the people. So it makes our life so easy. So these are the core capabilities and unique feature of Snowflake. So what we have learned in this Snowflake architecture chapter: shared disk and shared nothing architecture, and how does it work and what is the limitation of them. How Snowflake follows a unique hybrid architecture by combining the power of shared disk and shared nothing architecture. Snowflake 3 core layer and how does it function and what is their role. Why Snowflake is so flexible and virtually can scale to any number by using these 3 different layers. Snowflake at a glance, Snowflake capabilities and their unique features. Next, what's our next chapter? Next chapter is Snowflake Legacy Classic WebUI. Thank you for watching this Snowflake tutorial video series. If you have any constructive feedback or area of improvement or anything else, please share your comment. Refer to the description section below for additional documentation, tutorial links, and supporting reading materials. Please subscribe to my channel and press the bell icon to get notified of my latest videos and data engineering educational content. Please like and share the video with your team and other Snowflake enthusiasts. I have a disclaimer before I end this video. Snowflake Cloud Data Warehouse is a software as a service and hence upgrade itself more frequently and also enhances existing one and fixes bugs on a weekly release. By the time you finish watching this series, some of the feature will change or upgrade or become obsolete. Hence, my recommendation to my audience is to refer to the latest Snowflake documentation beside referring to my video content. So you can see a note below that some of the SQL behavior got changed. I also add those upgrades, updates, and deprecated item if applicable in the context of this video content in the description section, as well as pin them as my first comment so you don't carry any incorrect information from this video series. Thank you and happy learning.